Hello guys, so in this lesson we're gonna explore the test bench for this circuit in here. So after exploring the circuit itself, the design itself in the last video, in this video we're gonna see how to simulate and verify the functionality of this design. Basically this design has one simple problem. It has 6 inputs. So if we do the test bench like what we did with the AND gate, it will take a huge number of lines, to test or to have the combinations of each input. So we're going to start by 0, 0, 0, 0, 0, 0, and end up with 1, 1, 1, 1, 1, 1, 6, which are 64, combination. Fortunately, you can do looping in, VHDL. So I'm going to explain here the loops. So we have here 6 inputs. So this is basically the test bench here. I put here, same entity as our design lab 3 project. So basically copy and paste of this guy here. Then I defined, 7 signals. Please explore our first design of our first lesson, basically to know why we have signals here. So these signals is basically to connect the inputs or be connected to the inputs of, the design A, B, C, D, F, and the output Y. And of course, you should call them with different names. Then I started the design with the test bench. I instantiated, our design here and connect the signals to the inputs and outputs of this design. And then, we started this, putting values to these signals. So as I said, instead of having the 64 combination, which would be a huge number of lines, hundreds of lines, you can do looping. So A input here has 2 inputs, either 0 or 1. So I defined a counter called AA of type standard logic, and it has only 0 or 1. Okay, then I assign this counter to, A input. Same for B, same for C, same for D, same for E, and finally same for F. And after this, we wait for 1 nanosecond, just like what we did with the, the AND gate test bench. Here is the AND gate test bench, just to, so after putting a combination, we put a wait for 1 nanosecond. Exactly, this is what we have here. So for example, in the first iteration of each loop here, AN will be 0, BN will be 0, CN will be 0, DN will be 0, EN will be 0, FN will be 0. And then we wait for 1 nanosecond. Then this innermost loop will loop again, and F will be 1. So in the second iteration, we have 0, 0, 0, 0, 0, 1. This loop is finished. Then the third iteration, or the third, combination, you're going to have 0, 0, 0, 0. This will be 1. Then 0 again for Z. And so on, guys. Okay. So this will ensure for you to have the 64 iterations. Now let's simulate this. So simulate, start simulation, work. Then we choose our test bench here. It's called the lab 3 project. Test bench. So here our simulation environment. First we put the signals. You can just drag and drop the, your design in here. So here all the signals, inputs and outputs, everything is a design is now in here. Okay. So there is a problem here, a small problem actually. We don't have the truth table for this design. So we don't know when Y will be 0 and when Y will be 1 according to the inputs. But you can easily deduce a very simple, rule to know when Y is 1 when y is 0. Basically, y is equal to k or L. And remember, L is equal to N or M. So you can say that y equal to k or M or N. K or M or N. So it's an OR gate. So whenever k or M or N, any one of them is 1, y will be 1. And y will be 0 only if all of them are zeros. I mean, N is 0, M is 0, and the k is 0. Okay? So we need just to look at N, M, and the k and y. So here is N, here is M, here is k, and here is y. I'm gonna bring it, down here with this I up here. N, M, K, and y. Okay, so I'm gonna also mark these with different color, like this magenta color, for example. Okay. Also here you have, remember, you have 64 combinations. So if you set this to 1, like what we usually do, you're gonna have click here 64 times. So you can just write here 64, and with one click, this will bring up all the combinations at the same time. So let's do that. Just one click, we have it. Then we zoom out until we have the 64 combinations together. Like this. Yes. Yeah. So from 0 until 64 in here. That's enough for us. Now look at the magenta or the or violet color here, signals and the output y. So when all of them are zeros, so in the beginning here all of them are zeros. Okay, so y is 0. Then here one signal become 1, which is k. That's why y become 1. Then from that instant until that instant, one signal, which is M, is 1, so y is also 1. Then again, all of them here are zeros, so y is 0. Then here k is 1, y is 1. Then M is 1, so y become 1. Then again here, from that instant of time to that instant of time, all of them are zeros, so y is 0. And then from this instant forward, there will be at least one signal which is 1, so y will be 1 all the time. That's why from this instant of time and going forward, y is always 1. Okay, guys, that was it for this homework or this design. Thank you very much for watching, and see you in the next video. Bye-bye.